Welcome to the Physics New Era channel. In this channel, today we are going to take the MCQs regarding the oscillation chapter. So let us see the first MCQ. I'm going to read that. A particle performs a linear simple harmonic motion starting from the mean position. Its amplitude A, capital A, and a time period capital T at the instance when its speed is half the maximum speed. Its displacement is, so we need to calculate the displacement if its velocity is half of the maximum velocity. As we know the equation for the maximum velocity, so here what exactly the given factor, that speed or the velocity is equal to V maximum divided by 2. But before substituting all these values regarding the velocity, we know when the particle performing simple harmonic motion in SHM, in simple harmonic motion, we know the equation of velocity, that is given by V is equal to omega into under root of, here it is, A square minus X square. A stands for amplitude, X stands for the displacement from the mean position. And what about the maximum velocity? We know the maximum velocity it is given by, it is A omega, whereas A is the amplitude. This is the maximum. So seems to be, this is the maximum value of speed or velocity. Here it is. So we need to substitute all these values. Here, V value I need to substitute, and this V max value I need to substitute as a omega. So substituting here, omega into under root of A square minus X square is equal to A maximum, that is A omega upon 2. Here the cancellation factor we have, that is omega on the sides. So omega get cancelled. So let us square this so as to discard this square root. So squaring both the sides, and hence we are going to get this A square minus X square is equal to A square upon 4. Squaring a right hand side, A square upon 4. So we need to calculate this X. So if we are going to take this X to the right hand side, A square minus A square upon 4 is equal to X square. This is taken to the right hand side and this is taken to the left hand side. This plus become minus, minus become plus. So if we solve this one, this is 3A square upon 4. By taking the LCM, 4 it is multiplied with the A, that is 4A square minus A square divided by 4. That means 4A square minus A square, 3A square upon 4, which is equal to X square. So what about the X? X value it is given by, after taking the square root, here under root of 3, and this is A, because A square, if we are taking the square root of A, it is A. And what about the square root of 4? It is 2. So this is your expected answer. So which option it is correct in this one? So A option it is correct. A root 3 A upon 2, whereas this A is nothing but your amplitude, and here we are considering A as amplitude, so both are equal. So seems to be knowing this option is correct. Here we have the second MCQ before you. A body of mass 1 kilogram is performing a linear simple harmonic motion. Its displacement x centimeter. Obviously it is in CGS, we need to convert that into, okay, and at t second is given by x is equal to 6 sine of, in bracket, 100t plus pi by 4. Maximum kinetic energy of the body is, options are given: A 36 joule, B 9 joule, C 27 joule, D 18 joule. So we need to get this one of that option, correct option we need to choose. So let us calculate this. Before, what exactly the factor which are given here? So here the factors which are given, here mass it is given. Mass is equal to 1 kilogram. And we have given one equation which is given by x is equal to 6 sine of 100 t here plus pi by 4. Obviously, if we compare this equation with the x general equation, that is x is equal to a sine of omega t plus alpha. So if we compare, this is given in we say CGS form, so it is in centimeter actually, it is not mentioned in this one. So this is given, and here A means how much? If we compare with this one, A means 6 what? Centimeter. If you want to convert that into meter, it is given by 6 into 10 raised to power minus 2 meter. So this is your amplitude. What about this omega? If we compare the omega and this equation, here omega is equal to 100, and we know that omega is an angular velocity. So 100 radian per second. If it is so, what about the next alpha? Here alpha means the initial phase which is given by pi by 4 radian. So all these factors are given. So we need to calculate maximum kinetic energy. Kinetic energy maximum. So we need to get this kinetic energy maximum. So it is question mark. Before that one, what exactly the general kinetic energy equation? That is very important. General equation, it is given by half of m omega square in bracket a square minus x square is the general equation, and we need to get the maximum value. When exactly it is maximum? Kinetic energy is maximum when x is equal to 0. That means at mean position. At mean position. Seems to be considering that kinetic energy, it is maximum when x is equal to 0. Let us substitute this x is equal to 0. If we substitute, we are going to get half of m omega square a square. Because x is 0, so x square is also 0. So a square minus 0, a square. Substituting this value, half of, as we know that m is 1 kilogram. Here omega square, I am going to write 100 whole square into, what about the amplitude? That is 6 into 10 raised to power minus 2 whole square. If we are going to solve this one by one step, 1 by 2 into 100, I am going to write 10 raised to power 2 raised to power 2, because I am going to write this 100 as a 10 raised to power 2. Power to the power means it is get multiplied. Here also, here we have the square. Square of this 6 is 6 into 6, 36 into 10 raised to power minus 4 after squaring, and here 10 raised to power 4, that means 1 by 2 into 10 raised to power 4 into 36 into 10 raised to power 4 minus 4. So obviously in multiplication powers get added. So remaining power means the 10 raised to power 4 minus 10 raised to power 4. It is 10 raised to power 0. Any raised to power 0 is equal to 1. So 1 by 2 into 36, it is only the remaining factor. If you take the half of 36, it is nothing but 18 and it is in joule. So expected answer is option D. Expected answer is option D, which is given by 18 joule. This is your answer. Here we have the MCQ number 3. The length of seconds pendulum on the surface of the earth is nearly 1 meter. Its length on the surface of the moon should be, in bracket it is given, acceleration due to gravity g on the moon is 1/6 of that on the earth's surface. So which are the correct options? We need to choose one of the options. And first option 1 by 6 meter, B option 6 meter, C option 1 by 36 meter, and D option 1 upon under root of 6 meter. So let us work on this one. So here it is given the length of seconds pendulum, that I am going to write. Length of seconds pendulum, which is given by 1 meter. If it is 1 meter, its length on the surface of the moon should be how much? So length of the seconds pendulum on the moon is a question mark. But here it is given that general formula that L is equal to G upon pi square. But you will have to get the value after substituting G is equal to pi square when this value we are going to get when G is equal to, or length is equal to 1 meter. Obviously it is given that is 1 meter, and that's why G is equal to pi square. When I need to consider length of the second pendulum is 1, then and then only. Here it is. If we substitute 1, pi square, it is taken to the left hand side, means pi square is equal to G. That means G is equal to pi square. Substituting this value in this equation. But before that one, we need to calculate this. We know that length of seconds pendulum on the moon is equal to gravitational, we say, acceleration due to gravity on the moon divided by pi square. This is the formula. But we know that gravitational field acting is 1/6 of the gravity which is acting on the earth. So if we substitute this, I am going to get the value that is G by 6 upon pi square. But we know G is equal to how much? It is pi square. So pi square upon 6 upon pi square. So this pi square get cancelled. So length of seconds pendulum on the moon, and here it is length of seconds pendulum on the moon, which is given by 1 by 6. So which option it is correct? That we will decide. The option A it is correct. Means option A, that is 1 by 6 meter, it is the correct answer for this. Okay. So this one is the correct answer. Here we have the fourth MCQ before you. Two identical springs of constant K, or we say force constant, are connected first in series. See, first in series and then in parallel. Then in parallel means initially we need to consider the series and then parallel. A metal block of mass m is suspended from their combination. The ratio of their frequencies of the vertical oscillation will be in the ratio. Here, the first option A 1:4, B 1:2, C 2:1, and D 4:1. Among this ABCD, we'll have to choose one of that. But before that one, reasoning is very important. Now, see the diagram. Here in this diagram, here the force constant of this spring is K1. So since we consider this is the first spring, this is second spring, they are connected in series, and a metal block of mass m. Here it is the mass m and it is also mass m. But the same mass are likely to suspend on or below the spring. Here it is the combination is a series. It is in series but they are in parallel. ही एकसर जोडणी आहे आणि ही parallel म्हणजे समांतर जोडणी आहे. Okay, so seems to be considering here it is the first spring K1 K2, all these are having the K, means here the spring constant K1 is equal to K2 is equal to K. Just for the sake of knowledge I am going to take K1 and K2. Why? The reason is before you. As we know that in the series combination we have the formula, you will have to remember this formula, that is 1 upon K1 plus 1 upon K2 when they are in series. They are in series. I'm going to write here it is series. Series combination. It is started. So this is a series combination and we have the formula for this. So 1 by Ks is equal to, here cross multiplication means K1 or K2 plus K1, that means K1 plus K2 divided by K1 into K2. As per the rule, multiplying K1 with the K2, it is in denominator. K2 plus K1, or we say that K1 plus K2, 1 plus 2 or 2 plus 1, nothing. Okay. So if we are going to take the Ks is equal to K1 into K2 divided by taking the reciprocal. Okay. Here K1 into K2 divided by K1 plus K2. As we know, both are same. So I am going to write here it is. Here it is K into K, K square. K plus K, 2K. So one of that K it is cancelled. So Ks is equal to, see one of the, we say it is cancelled. So only remaining factor is K by 2 in case of series. You will have to remember this. This is for the series. What about the parallel? So parallel combination, parallel. In case of parallel, very simple, it is Kp, which is given by, here it is K1 plus K2, and we know that K1 is equal to K2 plus equal to K, that means K plus K it is equal to, we say K plus K it is equal to 2 into K, means here Kp is equal to 2K. So we have this formula and we have the second formula. This is for the series and this is for the parallel. Seems to be knowing K1 is equal to K2 is equal to K. You will have to remember that for the series we have this formula and for the parallel we have this formula, that is K1 plus K2, just addition of their force constants or a spring constants. So need to consider both the values. As we know, the series Ns or general formula N, which is given by N is equal to 1 upon 2 pi under root of K by M. K by M. How it came? Whether it is correct or wrong, here it is time period formula, T is equal to 2 pi upon omega and omega is equal to under root of K upon M. So T is equal to 2 pi under root of M by K, substituting, taking the reciprocal M by K, but in case of frequency 1 upon 2 pi, because we know that T is equal to 1 by N. So 1 by N means 1 by 2 pi under root of K upon M. This is the basic formula. For the series, we have this Ns is equal to 1 upon 2 pi under root of K in series divided by M. And this is seems to be considered as the equation number 1. And what about the parallel? Np is equal to 1 upon 2 pi under root of K P upon M. If we are going to divide or we need to get the ratio of these two, So ns upon np is equal to, here similar term get cancelled, here get cancelled, only in the square root ks upon kp. What about the ks? K by 2. What about this kp? 2k. So this k get cancelled. Only remaining factor is under root of 1 by 4. But if it is taken out of the square root, it is 1 by 2. That means ns as to np is equal to 1 as to 2. Means which option it is correct? Which option it is correct? The option is before you. The option B it is correct. Here we have the fifth MCQ before you. I'm going to read that. The graph shows variation of displacement of the particle performing simple harmonic motion with a time t. Which of the following statement is correct from the graph? The four statements which are given, that is A, acceleration is maximum at time t. Number B, the force is maximum at time 3t by 4. C option, the velocity is 0 at time t by 2. And a D option, the kinetic energy is equal to total energy at time t by 4. So here the diagram which is given. So I have already drawn the diagram and also written the options A, B, C, D in short. In that one, acceleration is maximum at time t. So this is the diagram before you. Let us divide the t. This is the complete one cycle time taken by a particle in one oscillation. We can term it as a single oscillation. So it will take a time t. This is known as a time period of oscillation. So let us divide this t into 4. This is a half part, so t by 2. This is 1/4 part, t by 4. This is 3/4 part, it is 3t by 4. So this is actually the displacement which is taken place. This is the amplitude. This is also lower amplitude, or we can term it as a plus, and this is as a minus amplitude. So seems to be knowing this is a negative amplitude and this one is the positive amplitude. That means the plus A and this one is a minus A. So this displacement, it is drawn horizontally, just like here it is. In case of, we say displacement x is equal to 0, that time initially it is at 0. Time is 0. Means here time t is equal to 0 initially. If it starts oscillating from this position, it reaches at this position. At the time it is t by 4. Later on, again it reaches to this position, it is t by 2. Again it reaches to this position, it is 3t by 4. And further, if it goes, it is equal to time t. Means it complete, to complete one oscillation. See, one oscillation, how? Here it is the particle. Here it is the oscillation. Again it goes to here and negative extremity and again mean position. As we know, this is the mean position, this is the extreme position, this is also extreme position. So let us get the answer. So one of these options it is correct. We'll have to get all these four because reasoning is very important. Without reason we cannot say that this option it is correct. So that's why I'm going to take all the reasons regarding the A, B, C and D, and then we will decide which one is correct. So let us take the acceleration is maximum at t. As we know the maximum acceleration formula, the acceleration which is maximum, it is given by maximum acceleration, it is minus omega square into x. But here it is maximum, whether it is maximum, that we will decide whether it is maximum or not. So I am going to write already the maximum and later on we will decide, because at time t, the displacement is a 0. Displacement is a 0. That means this value is 0. So acceleration is not maximum. It is not maximum it is 0. So it is not maximum. That means this option it is wrong. So let us take the B option. Whether it is correct or wrong, that I will decide. The force it is maximum at 3t by 4. Where exactly 3t by 4 is situated? It is at extremity. Whether it is situated at a positive extremity or negative extremity. So we need to get the force. But before starting the force, we will have to know F is equal to, we say, m into acceleration. This mass into this acceleration. So this will decide the force. So force, here the force is maximum. Where it is exactly the maximum? Where mass is constant, just A, it is maximum. But when the A it is maximum, when exactly this is situated at the extremity. Because as we know, A it is maximum. Where it is exactly maximum? It is maximum at omega square into A. When x is equal to plus or minus A. This indicates the direction. If it is positive A, it is at the positive extremity. It is a negative A, it is situated at the negative extremity. So it will decide when it is maximum, when it is omega square into A. So it is situated at this position, where at 3t by 4. At 3t by 4, x is equal to A. Or we say that x is equal to minus A as per the direction it is concerned. But I need to consider the magnitude. So this is the maximum value and the force is also maximum. So that is m into omega square into here amplitude, which is maximum. That means this statement, it is correct. Still we'll have to decide, or we'll have to check whether C and D is also correct or wrong. Okay. So let us check out that. Means this B option it is correct. Let us check out the C option also. But before starting, I am going to shift this to this left hand side. See, the velocity is 0 at t by 2. As we know, velocity is 0 at extreme position. Extreme position. Why? Because we know that V is equal to omega into under root of A square minus X square. If X is equal to, we say A, that means it is situated at extremity magnitudely. So we need to consider this as a 0. If we substitute X is equal to A square minus A square is equal to 0. That means V is 0 at extreme position. We know very well, but it is given. It is 0 at t by 2. T by 2 where it is mean, and V is maximum at mean. Why? Because we know that V is equal to omega into under root of, here it is A square minus 0. Why? Because at mean it is equal to 0 and V is equal to A omega, which is maximum. But it is shown that at mean means here exactly it is at t by 2, means it is at mean. So at mean V is maximum, but here it is shown it is a 0, means this is not correct. This is not correct. So what about the D? Let us check out the D. Here we know that kinetic energy formula, that is kinetic energy is equal to half of m omega square in bracket A square minus X square, and we need to decide question mark that it is equal to total energy, which is given by half of m omega square A square at what time? At t by 4. At t by 4 we know that x is equal to A. At t by 4 x is equal to A. Where exactly it is? T by 4 x is equal to A, that means it is having the maximum amplitude. Here x is equal to 0, x is equal to A, and x is equal to minus A. But here magnitudely I need to consider at this position 3t by 4, x is equal to minus a. But if I now want to take the magnitude of that one, it is not negative, it is plus. So at t by 4, at t by 4, where exactly x is equal to a. Substitute. If x is equal to a at t by 4, x is equal to a, that means this is 0, and this means it is nothing but your total kinetic energy, and this is your total energy, which is again question mark. And what about this? It is not equal to total energy because x is equal to a, so this is not equal. That means D option, it is also wrong. So only the right option is B. So correct option is B. The force is maximum at 3t by 4. Thank you.